A rod of length 5L is bent right angle, keeping one side length as 2L. The position of the center of mass of the system. Consider L is equals to 10 centimeter. Option A 5I cap plus 8J cap. Option B 4I cap plus 9J cap. Option C 3I cap plus 7J cap. Option D 2I cap plus 3J cap. This MCQ came in JEE Mains Shift 1 7th April 2025 examination. The total length is given to you as 5L. It is bent at right angle in such a way that horizontal rod is having length 2L while vertical rod is having length 3L. Diagram भी आपको guide करेगा इसके लिए. Alright. Now the value of L given to you is 10 centimeter. So can I say this 2L will be 20 centimeter and then this 3L will be 30 centimeter. Alright. So how to find out center of mass of this horizontal rod? This red dot is center of mass of this horizontal rod whose length is 2L. X1 comma Y1. Students, can I say this center of mass for 2L is lying on x-axis, so its y coordinate will be 0. What about the x coordinate? Yes, total length is 20 centimeter. X coordinate उसका exactly center पे होगा. Half of 20 centimeter will give you 10 centimeter. So x1 comma y1 is 10 comma 0. Alright. For this vertical rod, center of mass will be over here. Its coordinates are labeled as x2 comma y2, sir. Alright. So this point is lying on y-axis. So its x coordinate will be 0. What about the y coordinate, students? Half of this 30 centimeter should give you 15 centimeter. So x2 comma y2 is 0 comma 15. Clear? What about masses? Horizontal rod mass will be m1. Students, m1 आप मुझे बता सकते हैं कितना होगा? Can I say length is 10 centimeter? Let me assume for this length 10 centimeter, the mass is m. So can I say for this 20 centimeter mass will be 2m? Here I have to assume that linear density is constant for the rod. Mass per unit length remains the same. So for length L, right, the value is 10 centimeter. Mass I am considering as m. So for length 20 centimeter, it should be doubled, right? It should be 2m. And same way for this 30 centimeter length, it should be tripled of m, that is 3m, sir. So m1 हो गया 2m, right? What about m2, mass of this vertical rod? Tell me. It will be 3 times m. How you calculate center of mass x coordinate, right? X coordinate center of mass, sir. m1 x1 plus m2 x2, the whole over total mass of the system is m1 plus m2. Alright, students, what is the value of m1? 2m. x1 10 plus m2 3m multiplied by x2 0 divided by total mass, students, 2m plus 3m. Alright, that should give you 20m plus 0, the whole over 5m. So m will get cancelled. In the next step you should be getting 4, right? 4 centimeter. So center of mass x coordinate is equals to 4 centimeter. What about center of mass y coordinate, sir? YCOM, tell me. It will be m1 y1 plus m2 y2 divided by total mass is m1 plus m2. Tell me what is m1? 2m, y1 0 plus m2 3m, y2 15, the whole over 2m plus 3m. Alright. So this is now 0 plus 45m divided by 5m. So this should give you 9 centimeters, students. So x coordinate center of mass, comma, y coordinate center of mass you got recently, that's 4,9 centimeter, obviously, right? So as per the given option, it should be option B. Answer is given in terms of unit vector, right? So 4 I cap plus 9 j cap, because we all know I cap is a unit vector along x axis and j cap is a unit vector along y axis. All right, option B is the correct answer, beta. 4 I cap plus 9 j cap. If L vector and P vector represent the angular momentum and linear momentum respectively of a particle of mass m having position vector as r vector is equals to a times cos omega t I cap plus sin omega t j cap, the direction of force is option A opposite to the direction of r vector, option B opposite to the direction of p vector, option C opposite to the direction of L vector, option D opposite to the direction of L vector cross P vector. This question came in shift 1 4th April 2025 examination. Students, the given position vector looks like this. R vector is equals to A times cos omega t I cap plus sin omega t j cap. Mind you, over here this A is not the acceleration, this A is basically a constant. Alright. So I think using this position vector we can find out velocity. Yes, velocity v vector is given by dr vector by dt. Students, velocity will be rate of change of position with respect to time. Yes students, over here in this equation number 1, right, r vector equation number 1, A is a constant. I can take this outside the differential sign. Yes sir, the derivative of cos omega t I cap will be minus of sin omega t into derivative of omega t, which is omega separately, unit vector I cap as it is, plus what is the derivative of sin omega t, students? It will be cos omega t into derivative of omega t, which is omega separately, multiplied by unit vector j cap as it is. So simplified version will look like A times omega I am taking common, inside the bracket I am using this, minus sin omega t I cap plus cos omega t j cap. This is the formula for velocity vector v vector. This is my equation number 2. Getting this, students? Now using velocity, how can I find out acceleration, students? Come on. Acceleration is a1 vector लिखना पड़ेगा ना, because a जो given है in equation number 1, right, वो acceleration नहीं है. So I am purposely using some other denotation for acceleration, that is a1 vector. Students, acceleration a1 vector will be rate of change of velocity with respect to time, that is dv by dt. Here a is a constant. What about omega? Constant. Keep it outside derivative. Now what is the derivative of minus sin omega t, students? It will be minus of cos omega t multiplied by omega I cap unit vector as it is. Okay. Now then, what is the derivative of cos omega t, students? It will be minus sin omega t multiplied by omega unit vector j cap as it is. So what I can do now, a and omega already bracket के बाहर है. Inside the bracket I can take minus common, even omega common. So ये total omega square हो जाएगा, students. Inside the bracket you are getting now cos omega t times I cap plus sin omega t times j cap, students. Okay, so this is acceleration a1 vector. Let me consider this as equation number 3. Now do one thing, look at equation number 3 carefully. A times ये bracket वाला term, students, cos omega t I cap plus sin omega t j cap. Okay, so what I can do now, I can use equation number 1 and 2. Using equation number 1 and equation number 2, can I say acceleration a1 vector will be minus of omega square multiplied by ये येलो वाला जो मैंने अभी अभी हाईलाइट किया, कैन आई से a टाइम्स cos omega t I cap plus sin omega t j cap is your equation number 1 only. So I can replace that by r vector. Getting this, students? So using 1 and 2, I got the conclusion that acceleration is minus of omega square multiplied by r vector. Can I say, students, force F vector is mass times acceleration? So this will be mass multiplied by a1 vector. So that is minus of m omega square multiplied by r vector. Getting this, students? Using this recent equation, आपको समझा F vector is minus of m omega square times r vector, right? So this negative sign will help you to understand that the two vectors, one on LHS and one on RHS, are anti-parallel vectors. Okay, so F vector and r vector, right? That is force and position vector are anti-parallel vectors. That means, students, the angle between force and position vector will be 180 degree. So that means your answer should be option A, students. The direction of force is opposite to that of direction of r vector. Alright, completed. Which of the following are correct expression for torque acting on a body? Formula A, tau is equals to R cross L. Formula B, tau equals to d by dt of R cross P. Formula C, tau equals to R cross dP by dt. Formula D, tau is equals to I alpha. Formula E, tau equals to R cross F. It is given that R is position vector, P is linear momentum, L is angular momentum, alpha is angular acceleration, I is denoting moment of inertia, F is the force and T is time. Choose the correct answer from the following options given below. Option A, B, C, D and E only. Option B, C and D only. Option C, A, B, D and E only. Option D, B, D and E only. Alright, students, tau is equals to R cross L. ऐसा होता है क्या? बिल्कुल नहीं होता है सर. टाउ वेक्टर होता है, टाउ वेक्टर होता है, वेरी फेमस फॉर्मूला, हमने लेक्चर में भी कंसिडर किया हुआ है ये, राइट? टाउ वेक्टर इज इक्वल्स टू आर वेक्टर क्रॉस एफ वेक्टर. यस सर, नो सर? यस सर. So tau is equal to R cross L, where L is angular momentum. This is false. This is false. Alright, students, look at formula B. Formula B में given है tau is equals to d by dt of, tell me, R vector cross P vector, and yes, we all know this is tau vector. Alright, इसमें आप क्या करो? According to me, student, this formula is true. Now in case you are not knowing, एक बार सुन लो कैसे हैंडल करना है इसको. So tau vector is d by dt of r vector cross p vector. I am going to apply UV rule of my mathematics differentiation, right? So this is r vector cross dp vector by dt plus dr vector by dt cross p vector. Correct है ना students? One term as it is and you take derivative of second, then vice versa second time, and बीच में प्लस का साइन डालना होता है. करेक्ट है? ऑलराइट, बी ए गुड ऑब्जर्वर. हाँ बेटा, अभी टाउ वेक्टर इज आर वेक्टर क्रॉस डी पी वेक्टर बाई डी टी. ऑलराइट, प्लस स्टूडेंट्स, what about dr vector by dt? That's v vector cross with p vector. Linear momentum is m times v vector. Yes. So this simplified version looks like tau vector is equals to r vector cross dp vector by dt plus, just be a good observer students, as I told you recently, m बाहर ले सकते हो, mass is a scalar quantity, multiplication में you are going to obtain here v vector cross v vector. Now students, v vector and v vector are two parallel vectors, and for parallel vector, what is the answer of cross product? Tell me. This will be 0. बेटा, this will be 0. And that is the reason मैं कह सकता हूँ that tau vector is equals to r vector cross dp by dt. प्लस तो 0 ही है students. And later on आप यही tau vector को लिख सकते थे r vector cross, tell me what is dp by dt? Sir, this is nothing but force, very famous formula, right? Tau vector is equals to r vector cross f vector. So tell me b true हुआ कि नहीं? By assuming b that वो correct है, हमने पूरा आपको solve करके दिखाया. क्या क्या समझा स्टूडेंट्स आपको? tau is r cross f, so obviously formula E हो चुका है true, right? tau is equals to I alpha, हमारे रोटेशनल मोशन का स्टैंडर्ड फॉर्मूला. यू कैन स्टिल कंफर्म विथ योर ट्रांसलेटरी मोशन. F इज इक्वल्स टू मास टाइम्स एक्सीलरेशन, कंपेयर विथ F इज इक्वल टू ma इन केस रिकलेक्ट नहीं हो रहा है. tau इज I अल्फा, दिस इज ऑब्वियसली ट्रू. सोचना है हमको अबाउट फॉर्मूला C. बोलो बेटा, tau वेक्टर इज r वेक्टर क्रॉस dp वेक्टर बाई dt, इज इट करेक्ट? yes sir, that is correct. tau vector is r vector cross dp vector by dt, right? so ये भी तो ट्रू हो गया ना स्टूडेंट्स. so I think formula B, formula C, formula D, formula E all are correct. so this is going to match with option A, correct? option A में it is given that B, C, D and E all this are correct. A तो false हो गया ना बेटा, alright? A मतलब मैं फॉर्मूला ए की बात कर रहा हूँ. फॉर्मूला ए फॉल्स हो गया, ऑप्शन ए इज करेक्ट, जिसमें बताया जा रहा है फॉर्मूला बी, फॉर्मूला सी, फॉर्मूला डी एंड फॉर्मूला ई आर करेक्ट. ऑप्शन ए तुम्हारा आंसर है. ओके